Hello everyone, and welcome to Natural Language Processing with Python Part 2. In this section, we're going to continue right where we left off and start learning about text pre-processing. Since our main issue of our data is that it's all in text format or strings, the classification algorithms that we've already learned about so far actually need some sort of numerical feature vector in order to perform the classification tasks. There are many actual methods where you can convert a corpus of strings to a vector format. And the simplest approach is what's known as bag of words, where each unique word in the text will be represented by one number. Let's go ahead and jump to the Jupyter Notebook to see how we can do this. Alright, here I am at the Jupyter Notebook where we left off last time, and in this section we'll convert the raw messages, a sequence of characters, into vectors, a sequence of numbers. And as a first step, we're going to write a function that will split a message into its individual words and return a list. And we're also going to remove very common words, the, a, if, etc. These are known as stop words, and that's where we're going to be using the NLTK library. Remember, in the previous lecture, we actually downloaded these stop words. And we're also going to take advantage of Python's built-in string library. So we'll say import string, and the first thing we want to do is remove punctuation. I'm going to create a sample message called mess to show how this is going to work. We'll say sample message, exclamation mark, notice, colon, it has punctuation, period. So that's my mess. And now, if I say string dot punctuation, just tab autocomplete that, notice I have a string of a bunch of various punctuations. Now what I can do is use list comprehension in order to pass in for every character and check if it's not in the string punctuation. Let me show you what I mean by that. I'm going to say C for C, in mess if C not in string punctuation. And then we'll call this no punc. Run that, and now we'll check no punc. And this is now the elements in my original message, but notice now it's removed and left as a blank all the punctuation. So after notice, there's no colon anymore. At the end, there is no longer a period, and after sample, there's no longer an exclamation mark. Now let's go ahead and see how we can remove stop words. We can import a list of English stop words from NLTK, and you can reference the notebook or the documentation in case you want more information about this, but we can just say from NLTK.corpus import stop words. And then we're going to say stop words, words, and then pass in English. If we just run this, this will produce a list of all the English stop words. So these are just very common words that don't really tell you any distinguishing features. So these are such common words that when you're trying to do a spam or ham detection, or really any sort of classification of text data, these words are so common that they're probably not going to be very helpful as far as trying to distinguish one source of text from another. Now let me go ahead and grab no punc again. And since it's just a list of letters, what I'm going to go ahead and do is say equals dot join no punc. And this is essentially just a way of joining elements in a list together. And now if I look at no punc, it's back to its original string form, except now it no longer has punctuation. Let me just go over what's actually happening here with dot join real quick. So if we have an example string, we'll call it x, and I say A, B, C, D. Actually, let me go ahead and split this, so we'll put this as a list. A, B, C, D. So I have X here, A, B, C, D. I can use this join method, dot join, pass in a list of elements, and it will join them, and it will put in whatever string you put in here before join as their concatenation device. So if I put in like 3 pluses, it will join them with 3 pluses in between each element. Or if I join them with a bunch of random letters, it will join them with a bunch of random letters between each element, or an underscore, etc. So you notice that if I just leave a blank here, it essentially joins everything back together. And that's what happened with nopunc here, .join nopunc. And since we had spaces, it went ahead and just joined those spaces back together as well. All right, so that's how we worked that. Now we're going to go ahead and grab no punctuation. We'll say nopunc. It's back to that. Let's go ahead and split this again so we have a list. And now we have a list of all the words, which means we can now use list comprehension again to remove any stop words. And I'm going to say clean underscore mess is equal to, and using list comprehension, word for word in nopunc dot split if word dot lower, and we can go ahead and lowercase every word in here so we don't have to deal with capitalization, not in, and then we'll go ahead and type in the stop words. So that is going to be stop words dot words, and then pass in English. And then close this bracket off for the list comprehension. This is quite a long line, so let's go ahead and run it and see what we get out. Clean mess, and now we just have the most important words: sample, message, notice, punctuation. We went ahead and iterated throughout this list. We said give me for word and word in nopunc.split, which is this right here, if the lowercase version of that word is not in the stop words. And the stop words we removed was it and has, which makes sense because those are very common words. Now let's go ahead and put both of these together into a function that we can apply to our entire data frame. So I'm going to now put all of this into a nice function. I'll say def text underscore process, and it takes in mess. Remember, mess is going to look like our original string. It's going to look something like this, which is going to be, when we apply it, our text messages. We're going to apply this along this message column. So if we scroll back down, let me go ahead and make a doc string for this. First thing we're going to do is remove punctuation. Second thing we're going to do is remove stop words. And then we're going to just return list of clean text words. So let's go ahead and do that. We'll just go ahead and say nopunc is equal to, and instead of saying C, I'm going to say char for character in mess if that character not in string dot punctuation. And then I'm going to say nopunc is equal to blank string join nopunc. And then finally I'm going to say return the word for word in nopunc.split if word dot lower not in stop words dot words, and let me go ahead and scroll down and to the right, pass in English. Okay, let's go ahead and run this cell and create that function. So here we have this function. It's basically just the 3 steps we did earlier. And what we're going to go ahead and do is, if we check out our messages again, just ahead of that data frame, we have this message column. So what we're going to do is tokenize these messages. And tokenization is just a term to use to describe the process of what we just did, converting a normal text string into a list of tokens. And tokens are just the words we actually want, cleaned version of the words. And let's go ahead and see an example of the output on a column. So I'm going to grab messages, message. Let's go ahead and just grab the first 5 rows and then say dot apply text underscore process, the function we just created, and see what happens. And basically what happens is we remove any stop words and we create a list of these tokens, the important words we want. Alright, I also want you to be aware that there's lots of ways to continue to normalize this text data. We actually have only done very simple text normalization and pre-processing, and the NLTK library has lots of built-in tools and great documentation on a lot of other methods of normalization. For example, stemming is a really common way to continue processing text data. And basically what it does is if your text has a bunch of similar words, such as running, ran, or run, if you have those three words in your text data, basically these words are all the same thing. They're all just showing you different versions of the word run. So what stemming does is it tries to break all of these down and returns run. Now the issue of stemming is you need some sort of reference dictionary in order to do this, and NLTK comes with a lot of those built-in data sets and corpuses and references in order to do this easily. We'll go ahead and kind of explore these later on in your project, but for now, some of these text normalization methods can have trouble with shorthand, and you'll notice that we have a lot of shorthand in our SMS text data, such as na, or dun for done, or u, capital U instead of you. So stemming isn't going to work so great for our particular data set, and we'll go ahead and just skip that topic for now. What we're going to do instead is focus back on vectorization. And currently we have the messages as list of tokens, and now we need to convert each of those messages into a vector that scikit-learn's algorithm models can work with. What we're going to do is convert each message, which is again represented by a list of tokens, into a vector that machine learning models can understand. And I want to show you, just back to your lecture notebook, what the 3 steps we're going to do. I'm going to go ahead and open the lecture notebook and jump to it real quick. So again, now we're on vectorization in your lecture notebook. We just finished creating this function and applying it, and we had a little side talk about normalization, such as stemming. But we want to focus on vectorization now. And we're going to do 3 main steps for using the bag of words model. And I'm going to zoom in here. What we're going to do is count how many times does a word occur in each message. That's known as the term frequency. Then we're going to weigh the counts so that frequent tokens get lower weight. That's inverse document frequency. Then we are going to normalize the vectors to unit length to abstract from the original text length. That's known as L2 norm. And what we'll do is begin the first step. So here's a nice little kind of diagram of what that first step looks like. Each vector will have as many dimensions as there are unique words in that SMS corpus. And what we're going to do is first use scikit-learn's count vectorizer estimator object. And this model will convert a collection of text documents to a matrix of token counts. And that's the bag of words model. And we can basically imagine this as a 2-dimensional matrix where one dimension is the entire vocabulary, so 1 row per word, and then the other dimension are the actual documents, in this case a column per text message. So for example, each column is going to represent one message, so the first message, the second message, all the way till message number n, and then the rows are going to represent the words. So word 1, how many times did it show up in message 1? 0 times. How many times did word 1 show up in message 2? 1 time, etc., etc. Then the same for word 2, all the way for word n. So you basically have a very large 2-dimensional matrix of all the words and all the messages. Now, since there's so many messages and so many words, we can expect that we have a lot of 0 counts for the presence of words in that document. And because of this, scikit-learn is going to output what is known as a sparse matrix. And there's actually a link here to the Wikipedia page if you want to learn more about sparse matrices. But sparse matrices are basically a way of dealing with matrices that are going to have a lot of 0 values. So right here you can see an example of a sparse matrix. It has a lot of 0 values. So what you want to do is, instead of storing every single value and all the elements, you can store this as a sparse matrix. And you can go ahead and continue reading some of the mathematics behind a sparse matrix, but you can basically think of this as just a ton of zeros in your matrix, so you're going to save it in a particular format, so you actually save on memory in your computer. Let's go ahead and hop back to our notebook and continue on with the lecture and how we're actually going to use scikit-learn to perform the count vectorization. Okay, so the first thing we're going to have to do is say from sklearn.featureExtraction.text import count vectorizer. And then there's lots of arguments and parameters that can be passed to the count vectorizer. And in this case, we will just specify the analyzer to be our own previously defined function. So I'm going to do 2 steps here. I will say BOW for bag of words transformer equals count vectorizer. And if you do Shift Tab here, you will see that there's a ton of parameters here. In order to avoid having to pass in all those parameters, I'm just going to specify my own analyzer to be the text process function that we created earlier. And then I'm going to go ahead and fit this to my actual text data, which is messages and the message column. So I'm going to go ahead and run that. Now keep in mind, depending on how fast your computer is, this may take a while because you're essentially creating a very large matrix. All the rows are words, every single word in the messages, and all the columns are every single message. So you can go ahead and kind of sit back for a bit because this may take a while. All right, my computer's pretty fast, so it already finished it. And I'm going to go ahead and print the length of boottransformer.vocabulary underscore. And this is just going to print the total number of vocab words. Okay, so overall, it looks like we have around 11,000 words in our vocabulary. And what we can do is just take one sample text message and get its bag of words count as a vector, putting to use our new BOW underscore transformer, our bag of words transformer. So for example, let's go ahead and make an object called mess4. And from the messages data frame, under the message column, I'm going to grab the fourth message. So 0, 1, 2, 3, that's the fourth. Let's go ahead and print that message. So print mess4. Here we have that string, you done say so early, or you see already then say. Obviously not very clear English, but we'll continue on. And then we're going to say bag of words for, and we can grab our bag of words underscore transformer, call transform, and actually pass in that message as an item in a list. So we'll say mess4. And then if we check out what bag of words looks like just by printing BOW4, notice we get this out. And then we can also print out the shape of bag of words 4, so BOW4.shape, and it's won by our entire vocabulary. And this means that there are essentially 7 unique words in message 4, and that's after removing the common stop words. And then 2 of them, this one and this one, appear twice, and the rest only once. And we can go ahead and check and confirm which ones appear twice. And the way to do that is by, again, from your bag of words transformer, you can call the get feature underscore names method, close that, and then type in whatever index occurs here. So for example, 4068, if I go ahead and copy and paste that and run this, I get the letter U as a word. So U shows up twice, and we can see it here, U and U. And the other one shows up twice is at this index, 9554. So we can go ahead and grab that from the get feature names. And that's going to be the word say, and we can again see that say and say also show up twice. All right, that's it for part 2 of natural language processing with Python. In part 3, we'll go ahead and finish our bag of words transformation and then move on to TF-IDF, or term frequency inverse document frequency. Thanks everyone, and I'll see you at the next lecture.